Okay, in this example, we're going to show you how to compute a rate, which can be very useful when you're trying to compare frequencies across groups that are of unequal sizes. Right? So when your group sizes differ, you can't directly compare the frequencies for different events for those two different groups. You have to standardize them to a certain number of observations, and then you can create the rate and compare the rates directly. And so you'll recall that a rate is computed by taking the frequency of an event for a group, dividing it by the sample size for that group, and then multiplying it by a constant. And that constant can be whatever you want it to be. Choose some number that seems relevant for the size of the groups. And so, for example, what we might have is we might have a database of customer sales. Okay, and maybe we want to compare the sales for men and women. And we say, okay, so we've got males, and males make 100 purchases, and in our customer sales database we've got a total of 500 males. Now for females, we look at the database and we find out that females made 75 purchases, and we've got a total of 375 females. Now, if we just look at these frequencies, we might be tempted to say that males purchase more often than females. Certainly, in terms of raw frequencies, there are more male purchases than there are female purchases, 100 versus 75 between men and women. But we can also see that the total number, or the base sample size for these two groups, differs. There are 500 men and there are 375 women. So we would expect that there might be more purchases for men anyway, simply because we've got the same number or a larger number of men in the database to begin with. So in order to determine which one of these groups actually purchases more, we can compute a rate. And because we're talking about rates for groups that are in the hundreds of sizes, that are in the hundreds here, 500 men and 375 women, we'll make our constant equal to 100. So we'll calculate a purchase rate per 100 males and a purchase rate per 100 females. Okay, so to do that, what we'll do is we'll begin using our rate formula. For males, we'll say that there were 100 purchases divided by 500 males in our database, and that gives us a ratio of 0.2, and then we'll multiply that by 100 and we come up with 20 purchases per 100 males. Okay, so 20 purchases per 100 males. And we can do the same thing for females, and we'll take our 75 purchases for females divided by the 375 females in the database, and we get a proportion of 0.231. Then we'll multiply that by 100, our constant, and we'll get 23.1 purchases per 100 females. Okay, so now that we've done that, we've created these rates per 100 males and females, and what we find is that our rates for males are 20 and the rate for females is 23.1. In this particular case, even though there are fewer actual purchases among females, the rate, the standardized rate per 100 females is larger. For every 100 females that gets into our database, 23.1 make a purchase, whereas for every 100 males, only 20 end up making a purchase. And so this is one example of creating a rate to standardize the frequency of events to a constant population size or sample size.